We've recently talked about how to find the midpoint of a segment. So today what we're going to talk about is how do you find a point on the line that's a fractional distance but maybe isn't the midpoint. Okay, so just kind of to review real quick, A and B, you have points A and B, and M are on a number line, and M is the midpoint. So let's create ourselves a number line, and we've got A and B and M. Okay, so A is located at 4, B is located at 26, and M is located halfway between. Okay, so we know that this is A and we know that this is B. So how far is it from A to B? Well, on a number line, you just simply subtract your high minus your low. 26 minus 4, 26 minus 4 is 22. So the distance between points A and B is 22. The distance to M, so how far is it then to the halfway point? Well, half of the distance would be 22 divided by 2, which is 11. So the distance from A to M is 11, and the distance from M to B is 11. So then where would M be located? Now notice there's a difference between the distance and where it will be located. So the distance is 11 away from A or 11 away from B. So M would be located then at either 4 plus 11 or 26 minus 11, depending on whether you want to go to the left or to the right on the number line. So 4 plus 11 is 15. So M would be located at 15 on the number line. So what I want to point out is that there is a difference between the distance and the location. That's important. A lot of times students forget and they'll put the distance as the answer and not the location when I'm asking for the location. So we're going to start with a number line. So just on a number line, we have this number line we're going to use for 1 through 3. So it says, what is the coordinate of Q if it is 2/5 of the distance from A to B? So we're just going to look at this distance right here. And we want to go 2/5 of the way. So 2/5 of the distance. So 2/5 of the distance of means multiply. Well, the distance is how far is it from 20 to -5? Well, mathematically, it's the absolute value, and it's -5 minus a -20. Now, you can also just think, what does it take to go from -20 to -5? And that would be a positive 15. So the distance from A to B is 15. That's the total distance from A to B. So from here to here is 15. But I want to go 2/5 of that distance. So if I take 2/5 of 15, multiply by 2 over 5, you can let the calculator handle it. You can cross cancel. I like to do that. 15 divided by 5 is 3, times 2 is 6. Now 6 is how far, okay? So that is how far I want to be. How far away I want to be from where? I want to be 2/5 of the distance from A. So that means I'm going to leave from A. So I'm going to be 6 away from A. So if I take that -20 and I go to the right 6, then it would be -20 plus 6, which puts me at -14. So the location is at -14. Okay, that's an at. So it is 6 away from A, which puts me at -14 on the number line. Okay, so it's a percent or a fraction of the distance, the fraction times the distance. So find the coordinate, so that was Q. Find the coordinate of R so that it is 3/7 of the distance from D to C. So now we want the distance from D to C. We want to be somewhere on D to C in that segment. We want to be 3/7 of the distance from D. So from D to C is 28 minus 0. So the distance from D to C is 28. Now I'm writing out all the details. You might not write out all of those. And I want to be 3/7 of that distance. So multiply that distance times 3/7. 28 divided by 7 is 4. 4 times 3 is 12. So I am 12 away. I want to be 12 away from D. Okay, that's how far I want to be from D. Total distance is 28. 3/7 of the distance is 12, and I want to know where's the coordinate from D. Well, if I'm at D and I want to go towards C, then I have to go to the left for 12. If I go to the left 12, then I'm subtracting. So 28 minus 12 is 16. So I will be at 16 on the number line. So about right there. That is where R is. Okay? A fraction times the distance. Find the coordinate of x so that it is 9/11 of the distance from C to F. So from C all the way to F is from 0 to 55. So the distance from C to F, the length of CF is 55. I want to be 9/11 of that distance. So multiply that distance times 9/11, so it'll give me the fractional distance. 55 times 9 divided by 11, or if you want to do it mentally, 55 divided by 11 is 5, and 5 times 9 is 45. So I want to be 45 away from C, right? From C. So we start at C, and we want to go, so to be between C and F, we would have to go to the right to be on that segment. So I would go to the right 45. Well, 45 from 0 puts you at 45. So my point X would be right here at 45. It's 45 away from 0. So whether you add or subtract is dependent on the number line. And so you really want to pay attention to the picture at that point. Okay? Now, point Y is located 1/4 of the distance from X on segment XZ. Now there's a problem. I don't see a segment XZ, so I'm going to draw one. Okay, so we have segment XZ, and it says that Y is located 1/4 of the distance from X. So 1/4 of the distance from here. Well, let's just break this in half, and in half, and in half. So I took that segment, I broke it into 4 pieces because I wanted to be 1/4 of the distance. So I want to be 1/4 of the distance. So it says if point X, that's point Y, is located right here. There's Y. Now remember, we're on a number line. Technically these are lines, right? So we should go that way. So then it says if point X is at -3 and point Y is at 0, where is Z? So I want to know where on the number line is Z. Well, the good thing is we marked this into 4 equal pieces because we said we were 1/4 of the distance away. So this is basically what I have is I started with the answer and I'm working my way backwards to find out where the other coordinate was. Well, if this is 1/4 of the distance, well, how long is this? Well, this is 3. From X to Y is a distance of 3. That's 1/4. So let's go 2/4. So there's another 1/4. So now I've gone 2/4. Now I've gone 3/4. That's another 3. And then I go 4/4 all the way to the end, and that's another 3. So 3, 6, 9, 12 away from -3. -3, 0, then this would be 3, this would be 6, and this would be 9. So that says that 9 is where Z is sitting on that number line. Okay, and because we knew that this was 1/4 of the way, so we broke the whole thing into 4 pieces and then duplicated that 1/4 4 times until we found out where we needed to be. Now, we don't always find, we're not always looking for it on a single number line. Sometimes we're looking for it in a 2-dimensional graph. So let me kind of show you where this is going. So it says, what's the length of AB? So first, let's just find out how long AB is. Well, if I want to know this length, you have 2 choices. You can either use the distance formula or you can use Pythagorean theorem, whichever you're most familiar with. We have recently talked about the distance formula. So this point A is at -2, and B is at 6, 3. So if we use the distance formula, remember it's the square root of the difference between the x's, so 6 minus a -4 squared plus the difference between the y's, 3 minus a -2, and that's just straight from the formula. Clean up these double negatives. The calculator can handle it for you. 6 plus 4 is 10. 10 squared is 100. So that's 100. 3 plus 2 is 5. 5 squared is 25. So the length of this is the square root of 125. Now we always simplify our radicals. If you do your factors with this, then you get 5 times 5 times 3. We're going to take that square, right, that pair, we're going to pull it outside, so the square root of 5 times 5 is 5 times the square root of 3. The 3 was there and has to stay there. So that is the simplified version. It is approximately, oh, not 3, sorry, 5 times 5 times 5. Sorry about that. 25 times 5 is 125. That is approximately 11.8. So that's how long it is from here to here. Because when it's on a diagonal, we can't count it. I can count, say for instance, just a side note, like I know that that's 3, right? Because it's horizontal, I can count it. But I can't count when I'm on the diagonal. I don't know where 1 is. So the next question then says, where would point Q be located if it is 3/5 of the distance from A to B? Well, the distance from A to B is this. Here's where we run into a problem. So 3/5, if we did what we did before, 3/5 of the distance. Okay, so if we multiply 3/5 times 5 root 5, my 5's cancel out and I'm left with 3 radical 5, or approximately 6.71. Okay, so that's all well and good, but we have a problem. How do you count 6.71? Where is 6.71 on this line that is at a diagonal on the plane? You can't. You can't count 6.71. So there has to be another way to do it. And there is. Earlier I mentioned that I know that this is 3. So I can count horizontal distances and I can count vertical distances. So how about, instead of cutting through people's yards to go from one house to the other, what if I go around the block, over and up? And I find it that way. So let me show you actually how to work the problem, because what we just did doesn't work. So we don't want to do that. It's not helpful. Okay, that was the point. I wanted you to see that it doesn't work. So here's what we're going to do. We're going to go around the block, and we're going to we can't cut through people's yards, so we got to go all the way around. So I can count this horizontal distance. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So horizontally, I'm going to go 10. I'm going to go 10 blocks over, and I'm going to go 1, 2, 3, 4, 5 blocks up to get from A to B. 10 blocks over, 5 blocks up. So how about now I want to go 3/5 of the X distance and 3/5 of the Y distance. We're breaking, these are called horizontal and vertical components. Okay, so let's do 3/5 of 10. 3/5 of 10, 10 divided by 5 is 2, 2 times 3 is 6. So I want to go 6, either right or left. We'll figure that out in a second. And then I want to go 3/5 of my vertical distance, 3/5 of 5. Well, those 5's cancel out and leave me with 3. So I want to go 3 up or down, depending on what I want to go. I'll figure that out in just a second. So first, we want to find out what's my horizontal distance and what's my vertical distance. This is horizontal, this is vertical. Okay, this is in the X direction, this is in the Y direction. All right, so I want to go from A. From A. So let's go over here to A. Well, I have to go to the right in order to get to B, not to the left. So I'm going to go 6 to the right. 1, 2, 3, 4, 5, 6. And then from there, I'm going to go 3. And if I want to be on that line, I have to go up. So I'm going to go 3 up. 1, 2, 3. That is where my point Q will be located. It is at 2, 1. Okay, So you can't count on the diagonal, so we have to break it into horizontal and vertical components that we can see. Okay, so that's your thought process. If you're sitting down and you're trying to do this on a grid like this, and you realize I can't count, what can I do? I can count horizontally and I can count vertically. Okay, find the coordinates of P so that it is 1/3 of the distance from B to A. This time we're going from B to A. Again, I can't count, so I don't even need to know the distance of AB. Do you notice up here, I didn't end up actually using the distance from A to B to find out where it was located? Because I can't count it. I could calculate it, but then I can't count where it's supposed to go from there. So break it into its horizontal and vertical. You can either put the triangle down here or you can go up and over this way too. It doesn't matter where. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 if you need help keeping up with it, right? And then 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have a change of 6 horizontally and 9 vertically. I want to go 1/3 of the distance. Don't worry about where you're leaving from yet. Let's just find 1/3 of the distance. So in the X direction, it's 1/3 of 6. Horizontally, I'm moving over 6. So 1/3 of 6 is 2. Okay, 1/3 of vertically 9 in the Y direction is 3. So that means I'm going to go over 2 or up or down 3, depending on where I'm leaving from. Now this time I'm leaving from B. Now you got to think about where we want to go. So if I want to be on the line, then I have to go backwards because I got to travel along this line. So I'm going to go backwards 2, 1, 2. And then I'm going to go from there, I'm going to go up because that's in order to get to the line, I have to go up. I can't go down. I have to go up. Up 3, 1, 2, 3. And that is your spot. So 2 spots to the left, 3 spots up, and that's where your X marks the spot, and we put our point P. So P is at 1, 1. Okay? Again, you can't count along the diagonal, so finding the distance of the diagonal finding the length of that line on the diagonal doesn't help, okay? Because you can't then count to see what 1/3 of that distance is. Even if you could calculate it, but then you can't locate it and tell me where it lives. And that's what I want, is where, not how far. Now, the problem with this one right here is, notice how everything is, the scale is by tens, okay? And so I just want you to see what happens when your scale is off. How are you going to do it? It's not going to change any differently, but we're going to actually use these numbers instead of counting on the grid, because each one of these boxes is 10, not 1, and notice how they're not on the line. But that's okay. What we're going to do is this. So we're still going to do our horizontal and vertical distances, right? We still, even if we could calculate the length of this, which we can, even if I could take 2/3 of that distance, it wouldn't matter because I can't count to find out where that goes. Okay, so here's what you do. We need to know our horizontal distance. Well, our horizontal is based off of 16 to 88. So from 16 to 88. So think of this like 2 individual number lines, right? We have, go back to like the problems that we did at the very beginning. This is a little bitty number line. So 88 minus 16 is 72. So the distance that I'm changing horizontally is 72. The distance that I'm changing vertically, that's this. Here's my vertical from 84 to 18. So my vertical change, 84 minus 18, is 66. Okay, do the same thing that we did before. We need to know where it is, but we can't travel along this road. We have to go over and we have to go up. So how far over, how far up? So in my X direction, I'm going to go 2/3 of 72. So 2/3 of 72, you can let your calculator handle it or handle it mentally, however, whatever you want to do. 2/3 of 72 is 48. We'll deal with where it is in just a second. That's just how far. Y is 2/3 of 66. Okay, so 22 times 2 is 44. So that's how far. It's 48 away. It's 44 away. Now from where? The problem says from J. So I want to go from J, 44 down and 48 away. So since I'm going to trace the triangle, I'm going to go down first. So I'm going to go 44 down from 84. So 84 minus 44 is 40. So my Y, right, 84, and I go down 44, is going to put me right here at 40. So Y is going to be at 40. And then from there, I'm going to go to the right. So that means I'm going to take 16. I'm going to go 48 to the right. So I'm going to take that 48 and I'm going to add 48. And that's going to put me at 64 here. So I go down and then I go over, and it puts me right here. See, that would be hard to read. That spot on this graph would be hard to read. So that's at 64. So N is at 64/40. Find your horizontal distance, find your vertical distance, and then either add or subtract to go the direction that you need to go. I needed to go down, so I subtracted. I needed to go to the right, so I added, because I wanted to go from J to K and end up on the line. Okay, so when you are on a diagonal like this, when you have a line that has a slope, you can't calculate, well, you can calculate the lengths, but you cannot find the location of the point on the line with that distance, because you can't count along that line like you can when you're going in one dimension here. These you can actually count, but when you're on a slope, you can't do that. So that is how you find the fraction of the distance to find the location of the new point.